Objectives: students will demonstrate Newton's second law of motion, mainly momentum. We're going to build a momentum device. Here's the directions. And I'll try to get a copy of this, or most of this, on with the video down below. We have our craft sticks and 3x5 cards, stapler, and our scissors. And so we take a card just like it's demonstrating here. We're going to fold it in half. We'll cut it along the fold. It's folded in half lengthways. Actually give us two pieces. We can take either one. And now, as the directions say here, we're going to fold this in half. And take each one of these to get secondary folds. Use this as our guide to get the, we're supposed to fold here. And then this one on the other side. I'm actually going to fold this part up. So it looks something like this. We'll take the craft stick. These are the thin ones. You can use the thick ones too, as your stapler can staple into it. So I put this in the center. And take the stapler. Be careful not to staple ourselves. I'm going to do it on the other side of this. Of course, you have to be careful. Students, it's a concern. These staples are sticking up on the other side. I'm going to push this down with this handle a little bit and it'll get stuck. The thing when you're doing staples is don't worry about it. Focus in one. So now we have our momentum device in which we're going to place the penny on this side and this side, and hold one end as we pull back to create tension, and let it go and kind of use it as a slingshot as per the directions down here. Then they will answer the questions. What happens to the coin on the front platform when the device is activated? And also they'll say, to note the difference between what happens on the one on the back platform versus the one on the front platform. Real quick before we actually demonstrate. Is the distance of the coin on the back platform to the floor constant? So it's something to look out for. And part of this, like with any lab, we're going to do the simple version. Of course, if you want to do an actual experiment with this, what you could do is have a spot marked on the floor with tape or something, and how far you pull it back. We'll do 3 different light. You can either actually use a quantity or just a qualitative amount, like a little bit more. Depends on the level of your students. And you can even measure how far each one goes and repeat the experiment. That time actually turn it to an actual experiment where you're looking at the amount of force applied versus the distance the penny travels. And you can even mass the penny and calculate the speed and then calculate the momentum. This was much simpler. Like any of these labs, you can actually take it, start with a simple version and make it more complicated and more detailed. So you can actually layer, you can tier the lab to the levels of your different students with different learning abilities and different learning differences. You will have to have a lesson on vector diagrams so they can draw the forces acting on both coins, and then they'll note the different forces that are common to both coins. This particular question here, what would happen if you had a car at point C and it hit a car at point D? Circle the result of the collision. On this particular one, if you actually do a force diagram like it's taught, none of these, unless I'm mistaken, someone can put down in the comments if I'm mistaken on this, but none of these are the resultant. This would actually be the resultant. So we actually had to add an answer in here because none of these are correct unless I'm doing it wrong. I don't think so. Because if you add these either direction, this one, arrow the tail on this one, or vice versa, you still end up with a resultant vector force in this way. And there's no measurements here, so it's just direction. So be aware of that. Okay, so we're going to actually perform our experiment. It's not a true experiment. We don't have an independent versus dependent variable. As I mentioned before, you could always mark on the floor how far back you pull. You can do 3 different levels. And of course repeat the experiment and then even measure how far each of the pennies move and write that down in a data table and make a graph and make it into a full lab to analyze and come to conclusions on. This is just the basic. So the direction is you pull one in and pull back, and we'll do lightly, and we note the difference between the movement between the front penny and the back penny. Now of course Socratic methods is going, okay, which direction was the force, which direction the penny move, and why didn't that one move versus how the force is different acting on each of the pennies. I'll do this. And that time I tried to go back just about the same amount. That's why I probably would have a good idea to have a set spot. That's actually. See, I was pushing down on that, so probably push on that. You notice this changes the angle on that, which is also going to change your results. So depending on how much detail your students are looking, you can actually have them figure out what other variables could be affecting the results. So they just went about the same distance. Now we'll add a little more force, pull it back a little more. The back penny doesn't move much. And probably because when that slings forward and comes back, the backward motion is moving a little bit. I used a lot of force in that, and it went way down the hallway there. I do not have the proper shoes on for a lab. Increase the force again. Of course, it's popped up that time. And drawbacks is trying to keep this level up, pushing down on it while you're doing it. But that's essentially the lab. And like I said, you can always turn this into a more detailed lab for your students at different levels by actually measuring how far the penny travels, versus how much force is being applied on that. And if you have the device, you can even measure, you have the little force scales. You can measure how much force you're putting on that and have that added in too. And you can film it or have a timer, any number of things to calculate the speed and multiply by the mass of your penny to figure out the momentum of your pennies. Or you can take a number of pennies and tape them together and increase the mass and see how that, with the same applied force, and have that as your independent variable and play around with that. So there's a number of things you can do, take the simple lab and make it more complicated, more detailed, and make it into a full lab. That's it. Now hopefully these questions come through clearly. I'm going to also try to copy and paste these. These are a series of these labs activities are from University of Texas at Dallas, and they are used, meant for general use by science teachers anywhere. If you found this useful and enjoyed it, please hit the subscribe and the like button, and I'll try to produce more. And some of these labs will be more complicated. This one have a little more detail, but these are quick, fairly easy, accessible labs for I said anyone that's at a district in which they need to do these sorts of labs to have hands-on activity, or if you're homeschooling or something and you need something that's quick and simple and not overly pricey. Thank you for your time and your attention.